Okay. Now our next keynote speaker is Gila Sher from the University of California. Hello, Gila. Can you hear us? Okay? Everything is okay?
Yes, I can hear you.
Welcome to High School of Economics. And the title of her talk is excellent, Truth, Realism, and Discovery in Logic. So welcome. Please share your presentation.
Okay, do you see my slides?
Yeah.
Yeah, can you hear me?
Okay. Yeah.
Yes, okay, so first let me say that I'm very pleased to be with you in this conference. Unfortunately, I cannot be in person and cannot attend all the talks, but it's still a real pleasure to be here. And I'd like to thank Elena for inviting me. And the title of my talk is Truth, Realism, and Discovery in Logic. This talk is indirectly inspired by Ben Martin's and Ole Hjortland's paper, Anti-Exceptionalism About Logic as Tradition Rejection. According to Ben and Ole, anti-exceptionalism about logic is a cluster of views that diverge from the traditional conception of logic by rejecting or changing some properties traditionally attributed to it, such as formality, analyticity, necessity. And they rightly include me in this category. In this talk, I will offer non-traditional answers to three philosophical questions. One, the question of truth. Is there truth in logic? What kind of truth? Correspondence, coherence, pragmatist truth, some other kind of truth? Two, the question of realism. Is there objective fact of the matter about whether a given sentence S follows logically from a set of sentences gamma? What kind of objective fact of the matter? And three, the question of discovery. Is there discovery in logic? What kind of discovery? Surprisingly, these questions have been barely discussed in the recent literature. My answers to this question have direct consequences for the properties traditionally attributed to logic as well. One, the question of truth. Is there truth in logic? What kind of truth? Correspondence, coherence, pragmatist truth, some other kind of truth? How should we approach this question? One common way, look at the use of logic in natural language. Now, I'm a big fan of natural language. It's hard to think of something more important for the development of human civilization. But I'm not a fan of answering philosophical questions by looking at natural language. Why? Natural language was created a long time ago. It reflects views of the world that we no longer have. It fulfills many functions, including functions like the expression of emotions that have very little to do with truth, realism, and discovery. For example, the semantic principle that whenever we use a proper name or an individual variable, we are committed to the existence, real existence, existence in the world of an individual, seems to me unreasonable. It's one thing to determine what individuals exist, and another thing to use a given linguistic device to refer to them. For example, it's possible that there are no numerical individuals in the world, and we use numerals to refer to second-level cardinality properties, that is, properties of individuals in the world. Asserting 1 + 2 = 3 does not commit us to the existence of mathematical individuals. It's just a convenient way of saying the disjoint union of the cardinality properties 1 and 2 is 3. Disjoint union of 1 and 2 is 3. I will return to this later on. An alternative way to approach the question of truth in logic is to focus on knowledge instead of language. This approach, in turn, can focus either on 1, the practice of using logic in knowledge, say in science and mathematics, or on 2, the role or function of logic in knowledge. Tarski, in his 1936 paper on logical consequence, focused on 1. I prefer to focus on 2 while keeping 1 in mind as well. So what is the function of logic in knowledge? And where does truth enter into the picture? To answer this question, we need to start with a few observations on knowledge, human knowledge. Here are 3 basic observations that are relevant to our questions. 1. For one reason or another, humans desire to know and understand the world as it is, both practically and theoretically. But 2, our cognitive resources are significantly limited, and this renders the world highly complex relative to our epistemic abilities. We are prone to error. Yet, 3, in spite of our limitations, we have significant cognitive resources, including innate and acquired cognitive abilities, such as sensory perception and intellect, as well as the capacity to actively manage our quest for knowledge, ask questions, initiate investigations, design experiments, build tools, etc. 1 to 3 together imply that we need to distinguish between correctness and error. We need and also can distinguish between correctness and error, minimize error, and maximize correctness. This is where truth and logic enter into the picture. Let me start with truth. Being prone to error, we need a norm or a standard of correctness for our theories. The norm of truth satisfies this function. Note, some would say that justification can replace truth in this role, but this is not the case. Not only is truth not equivalent to justification, but justification requires some underlying principle like truth to guide it. How we go about justifying our theories, if our goal is, say, simplicity or practical utility, is very different from how we go about justifying our theories if our goal is or centrally includes truth. Given our desire to know the world as it is, truth or something like it is required to guide epistemic justification. But what kind of truth is needed for human knowledge? Correspondence, coherence, pragmatism, other? Given our goal of knowing the world as it is, we need a norm of truth that says a sentence or a theory is true if and only if whatever it says about its subject matter, some facet of the world, holds in the world of this facet. It is for this reason that the epistemic function of truth requires correspondence truth or something like it, rather than coherence truth or pragmatist truth. The norm of truth we need is a correspondence norm. But the correspondence norm we need is not bound by the unreasonable, naive, narrow constraints of traditional correspondence. The correspondence relation between true statements and their target in the world need not be one of copy, mirror image, or even direct isomorphism. For a sentence theory to be true, it must be systematically connected to its target in the world, but it does not have to be a copy of its target in the world. What form or forms the correspondence connection takes is an open question. The norm of truth sets a strong constraint on our theories, but it is flexible with respect to the patterns that connect true theories or sentences to the world. The correspondence value of truth is, in this sense, a pluralistic correspondence value. The correspondence pattern can be direct or indirect, simple or complex. What its structure is depends on one, how the world is in a given field of knowledge, and two, how we humans can and do cognitively reach this area of the world. How do we determine whether a given field of knowledge X is truth apt? We begin by asking, is there something in the world such that to know it we need field X? If the answer is positive, field X is truth apt. Otherwise, it is not. This is how I think of correspondence with respect to, e.g., mathematics. First, I ask, does the world or things in the world have formal or mathematical properties, relations? It is quite easy to see that the answer to this question is positive. Take, for example, this Zoom room. In this Zoom room is part of reality. There are people in it, and there are pictures of other things like tables and chairs and bookcases and so on. All these are real things. But they are not the real things in this part of the world. It is also a real thing that some of the objects here have the property of being a person. This is not a formal property. But all the people here also have the property of being self-identical, and this is a formal property. So self-identity is part of the world. Furthermore, if you take the property is a person in this Zoom room, then there's a fact of the matter whether this property has cardinality 2 or cardinality 20 or cardinality 50 and so on. So the cardinality properties, second level cardinality properties, are also part of the reality of this room. There's a fact of the matter of what is the cardinality of the property is a person in this room. Or take the relation of having one's picture right next to someone else's picture. This relation of, let's say, sitting next to is a relation, real part of the reality of this room. But this relation too has formal properties. For example, it's non-reflexive, it's symmetric, and it's non-transitive. So there are many formal features of the world which are part of the real world. And we may assume so formal mathematical properties are real, part of the world. But if formal properties are real, they are likely to be subject to laws, and it is natural to view mathematics as the discipline studying these laws. So there is room for truth, correspondence truth in mathematics. Next, we ask, how do we humans access mathematical properties of objects in the world, such as cardinality properties? My answer is, in principle, we can access them either directly or indirectly. Now, cardinality properties are second level. If we access them directly, then mathematical theories will be primarily second level. But it's possible that we humans are better at figuring out things when we think about them in first level terms, i.e. in terms of individuals and their properties, rather than in terms of properties and their properties and their properties and so on. In that case, we could introduce mathematical individuals, numbers level 0, as posits, and talk about cardinality properties indirectly, using first level discourse and indirect reference and correspondence. Thus, whereas the correspondence pattern of physical statement is direct, language Earth is a planet is true if and only if in the world the individual Earth level 0 has the first level property of being planetary, the correspondence pattern of mathematical statements will be indirect. On the level of language, the number 1 is odd is true if and only if. On the level of posits, the 0 level individual 1 has the first level property of being odd, if and only if in the world, the second level property 1 has the third level property of being odd. This explains the example I gave earlier when I said that language is not a reliable guide for philosophy. Just because language developed in such a way that we use individual constants and variables in mathematics does not mean that we are committed to the existence of mathematical individuals. Individual constants or variables may represent indirectly higher level mathematical properties such as cardinality properties. These epistemic considerations lead us to view truth as correspondence in a broad, flexible, non-naive way. At this point, however, you may wonder whether truth is a norm or a property. Isn't truth a property? Yes, it is a property, the property associated with the norm of truth. But isn't the property prior to the norm? Neither is prior to the other. They are interconnected. There are a number of properties in the neighborhood of truth, correspondence, coherence, pragmatism. All are bona fide properties, but the norm of truth says that it is the correspondence one that fulfills the function of truth. Yet without the property of truth, there cannot be a norm of truth. The same holds with respect to justice. There are both a norm and a property of justice. Neither is prior to the other. The two are interconnected. We have seen that truth is a correspondence, norm, and property, but not a traditional correspondence, norm, and property. It is a non-naive correspondence, norm, and property, one which allows multiple patterns of correspondence. We are now ready to turn to logic. What is logic's function in knowledge? We have seen that one result of our cognitive limitations is that we need a norm of truth. Another result is that we need shortcuts. We cannot discover each facet of the world individually. This is where methods of inference or consequence enter into the picture. We would especially benefit from having a general method of inference, arriving from truths that we already know to truths that we don't yet know. One of the main functions of logic is to provide such a method. Another is to prevent catastrophic errors of the kind we call contradiction. Here I will focus on the former function. Now, inference transmits something from premises to conclusion. What? And one. Because our goal is true theories of the world, i.e. correspondence truth, logical inference or consequence needs to transmit truth, truth in the world, correspondence truth from premises to conclusion. And it's also very desirable that logic provide a strong method of transmitting truth, one that works in all or most fields of knowledge, and even for cases we have not encountered yet, but might encounter counterfactual cases. So the task or function of logic in knowledge is to provide a method of inference, consequence, that transmits truth from premises to conclusions with a considerable modal force. A logically implies B if and only if A transmits truth to B necessarily. But can this task be fulfilled? I think it can, and I reason as follows. If the world has certain features that are governed by highly necessary laws, then we could use our knowledge of these laws to create a modally strong method of inference or consequence, a method that transmits correspondence truth from some sentences that are true in the world to other sentences that are true in the world, expanding our knowledge to the letter in one fell swoop. This is what we are looking for. Features or properties F1, F2 in the world, such that from the bottom to top, in the world, there's a law that connects F1 to F2 necessarily. In the world, accordingly, whenever there's a situation C1 that have feature property F1, this necessitates a situation S2 that has F2. And this guarantees that the truth of the sentence S1, which is true if and only if situation C1, F1 holds in the world, guarantees the truth of sentence S2, which is true if and only if situation C2, F2 holds in the world. And this in turn necessitates the logical consequence S1, therefore S2. Question, are there such properties as F1 and F2? Yes, formal properties are of this kind. Properties like identity, complementation, union, intersection, inclusion, cardinality properties such as at least one, having finite cardinality, etc. Note, at least one is the same property as non-emptiness, which is the existential quantifier property. There is at least one P is the same as P is non-empty, is the same as for some X, Px. Now, all the standard logical constants and the properties they denote are intuitively formal. For example, logical constant identity, logical property identity, negation in the context not Px, complementation, conjunction in the context P1x and P2x, intersection, disjunction in the context P1x or P2x, union, conditional in the context P1x, if P1x, then P2x, inclusion, existential quantifier, non-emptiness or has cardinality larger than or equal to 1, and universal quantifier, universality in a given domain, and the defined a logical constant for there is exactly one and has cardinality n. And this explains how and why such a logical consequences such as for some x, ax or bx, for all x not bx, therefore for some x, ax work. On the level of the world, we have the law non-emptiness of the union of any properties A, B plus emptiness of B necessitates non-emptiness of A. This guarantees that the truth of for some x, ax or bx, for all x not bx, guarantees the truth of for some x, ax. And this guarantees that for some x, ax or bx, for all x not bx, logically implies for some x, ax. This explains why the above inference consequence transmits truth, correspondence truth, from premises to conclusion, and does so with strong necessity. Now we have seen that the function of logic requires that logic transmit correspondence truth from premises to conclusion with a strong modal force. We have also seen that the inference for some x, ax or bx, for all x not bx, therefore for some x, ax does that. This logical consequence is true. What kind of truth does this logical consequence have? Correspondence truth. This metalogical sentence is true because in the world, the non-emptiness of A union B plus the emptiness of B necessitates the non-emptiness of A. We have answered our first question, the question of truth. Is there truth in logic? What kind of truth? Correspondence, coherence, pragmatic truth, some other kind of truth? Our answer is yes, there is truth in logic. Logical truth and logical consequence claims are correspondence true. From here, the answer to our second question is quite straightforward, the question of realism. Is there objective fact of the matter about whether a given sentence S follows logically from a set of sentences gamma? What kind of objective fact of the matter? Our answer is there is an objective fact of the matter about whether a given sentence S follows logically from a set of sentences gamma. This objective fact of the matter is formal. Gamma logically implies S if and only if a corresponding formal law holds in the world. In our example, for some x, ax or bx, for all x not bx, therefore for some x, ax, holds if and only if the non-emptiness of the union of two properties and the emptiness of the second necessitates the non-emptiness of the first. Finally, we get to the question of discovery. The question of discovery. Is there discovery in logic? What kind of discovery? Our answer is there is discovery in logic. What kind of discovery? Discovery of the formal laws responsible for logical truth and consequences. In our example, discovery of a certain formal law governing unions, complements, and non-emptiness of properties. I.e., we discover that the sentence for some x, ax, or bx, and the sentence for all x not bx logically imply the sentence for some x, ax by discovering the formal law that non-emptiness of A union B plus emptiness of B necessitates non-emptiness of A. Now, our answers to the questions of truth, realism, and discovery in logic enable us to evaluate whether logic has the traditional properties attributed to it in the philosophical literature, for example, formality, analyticity, and necessity. Formality, yes. Analyticity, no. Necessity, yes. Let me elaborate a bit more about the formality, necessity, and non-analyticity of logic. Formality. Formality means different things in different contexts. In logic, it often means syntax. This is not the notion of formality I use here. I use formality in an objectual sense. Objects have properties of many kinds. Some are formal, others are not. Is a student is not a formal property, but is identical to and is non-empty are. What is formality? Not intuitively now, but systematically. Systematically, we can explain formality in terms of invariance. For the present terminology I'm using, you can look at my booklet, short book, Logical Consequence in the Cambridge Elements. Invariance is a central topic of interest in both science and mathematics. But the invariance used in the foundation of logic is a bit different. It is property invariance. Let me explain. Every property whatsoever has some degree of invariance. What does this mean? It means that every property remains the same under some one-to-one and onto replacements of individuals. Example, the property is a human. If we replace individuals that are men by individuals which are women in a one-to-one manner, the property is a human will not notice, so to speak. It is invariant under such replacements. Most properties are not invariant under all one-to-one and onto replacements of individuals. For example, is a human is invariant under replacements of men by women, but not under replacements of men by numbers. If we replace Biden by the number 1, is a human is not preserved. Biden has the property is a human, but the number 1 does not. But some properties are invariant under all one-to-one and onto replacements of individuals. For example, self-identity. Take again the individual Biden. Biden has the property of self-identity. Now replace Biden by any other individual. That individual also has the property self-identity. Self-identity is invariant under all one-to-one and onto replacements of individuals. Let us call a property or a relation that is invariant under all one-to-one and onto replacements of individuals a maximally invariant property. I should say as an aside that this is equivalent to the notion of invariance under all isomorphisms. But for the present purpose, maximal invariance is more natural. Is self-identical, is identical to, and is non-empty are maximally invariant. Is self-identical? We just saw this now. Identity, take any individuals A, B, and replace them by any individuals in a one-to-one and onto manner. Say, that is, replace A by R of A, B by R of B, where R is a one-to-one and onto function. It is easy to see that identity is preserved. A is identical to B if and only if RA is identical to RB. So identity is maximally invariant. Is non-empty. Let D1 and D2 be equinumerous domains of individuals. Let R be a one-to-one and onto function from D1 to D2. Let P be a property of individuals in D1, any property. Then R induces a replacement of P by a property P prime of individuals in D2. It is easy to see that P is non-empty in D1 if and only if P prime is non-empty in D2. For example, if we replace boys by girls in a one-to-one manner, then the property is a boy is non-empty in D1 if and only if the property is a girl is non-empty in D2. So is non-empty, the existential quantifier property is maximally invariant. Now let us define. P is formal, is by definition, P is maximally invariant. It has been proven that 1, all the standard logical properties, and 2, all higher level mathematical properties are maximally invariant, i.e. all these properties are formal in our sense. We can now see why the logical consequence for some x, ax, or bx, for all x not bx, therefore for some x, ax is formal. The existential quantifier, disjunction, universal quantifier, and negation denote the formal properties non-emptiness, union, universality in a given domain, and complementarity in the given domain. And the logical consequence is grounded in a formal law governing these formal properties in the world. We have seen why and in what sense logic is formal. Now let us turn to the necessity of logic. The necessity of logic follows from its maximal invariance, formality. How? Maximal invariance, formality of properties implies the necessity of their laws. First, let us note that the maximal invariance of the logical properties is preserved when we expand our domains to domains of counterfactual individuals. Say, self-identity is invariant not only under one-to-one and onto replacements of Biden by any actual individual, but also under replacements of Biden by any counterfactual individual, say Hamlet. Now, if a property does not distinguish between two individuals, actual or counterfactual, the laws governing it cannot distinguish between these individuals either. Otherwise, they will not be laws of this property. And if a property is invariant under all replacements of actual counterfactual individuals, then its laws must hold in all actual counterfactual domains, i.e. its laws must be necessary. So in general, formal laws are necessary. Examples: if identity does not distinguish between Biden and Hamlet, the laws of identity cannot distinguish between them either. And if non-emptiness does not distinguish between Biden and Hamlet, the properties of both Biden and Hamlet are non-empty, then the laws governing non-emptiness cannot distinguish between them either. So the laws of identity and non-emptiness, the existential quantifier, do not distinguish between any domains of actual counterfactual individuals. If they hold in any, they hold in all. Since they hold in some, they do hold in all, i.e. the laws of identity and non-emptiness are necessary. And in general, formal laws, laws of formal properties are necessary. Now, logical consequences are grounded in formal laws. As such, logical consequences are necessary. In our example, since the logical consequence for some x, ax, or bx for all x not bx, therefore for some x, ax, is grounded in a formal law, which as such is necessary, this logical consequence is necessary. We have seen that and why logic is both formal and necessary. Now let's see why logic is not analytic. This too follows immediately from the formality of logic. Logic is grounded in formal laws governing the world, Therefore, it cannot be purely linguistic, based only on linguistic conventions. Still, someone may ask, question, originally you said that to play its role in knowledge, logic must transmit truth, correspondence truth, from premises to conclusion. Can this not be done through linguistic conventions? My answer is yes and no. Yes, it is possible to create linguistic rules that simulate the formal laws governing the formal properties denoted by the logical constants. For example, the usual rules of inference are of this kind, rules of proof are of this kind. No, but this does not make logic analytic. It is not inherent in our language that it simulates the formal laws governing the world. Those who say that logic is analytic normally think that whatever linguistic rules would govern the behavior of logical constants, logic would behave according to these rules. And such a logic would be as good as any other logic. But this is not the case. For example, language by itself does not forbid us to use the following conditional rule affirming the consequence. If A, then B, B, therefore A. But we know that affirming the consequence does not transmit truth from premises to conclusion. So it's not just a matter of language that this is not a correct logical law. Worse still, some philosophers say that logic is just a language game. Any logical game is as good as any other. Not only is this incorrect, the difference between logical games can be a difference between life and death. Example, consider the following logic, which I will call Davka logic. Davka is a Hebrew word which means willfully, spitefully, deliberately doing the opposite of what you are expected to do. And now in this logic, we have two rules. Modus Davka says, if A then B, A, therefore not B. And double negation, the usual rule, A, if and only if, not A. Now consider the following inference. If a car comes, don't cross the street. If A, then not B. A car comes, A. Therefore, cross the street, B. Davka logic can kill you. The logic game, Davka logic, is not as good as any other logic. Conclusion. In this talk, I gave non-traditional answers to the questions of truth, realism, and discovery in logic. 1, truth. Yes, there is truth in logic, correspondence truth, but not traditional correspondence. There is non-naive correspondence. Realism, yes, logic is grounded in formal reality, formal facets of reality. Discovery, yes, discovery of formal laws grounding logical truth and consequences. There is, of course, a whole lot more to say about logic from this perspective. I'm looking forward to your comments and questions. Thank you.
Thank you, Gila, for excellent talk. Questions? Sergey, welcome.
Yes, I always have a question. Gila, we're on the same continent. I'm New York, and I guess you're in San Diego now, yes?
Right.
Yes, so listen. A clarifying question, because it's a very, very big painting which you just delivered, touching many, many aspects. For me as a logician, I'd like to understand, and just the clarification question, are your views compatible with the views of truth by like Brouwer, Tarski, and Kripke?
Okay.
And who is closer to you, who is not?
Okay. The closest to me is Tarski.
Well, naturally, geographically, yes.
Yeah, but not just geographically, also philosophically and logically.
Yeah.
In his 1933 paper, Tarski said that the notion, a paper on truth in formalized languages,
Yes.
Tarski said that truth, the notion of truth he's interested in is the classical Aristotelian notion of truth, which he identified as correspondence truth.
Okay.
Furthermore, both in the 1933 paper and in his 1936 paper, not the one on logical consequence, but another one, I forgot now its name, something about semantics, Tarski says that what does it mean that a property is a semantic property like truth? What is semantics? And he said, semantics has to do with the relation between expressions of the language and objects in the world. And so this also suggests that for Tarski, semantics in general is a correspondence notion. Okay, and that includes reference and satisfaction. Something in the world satisfies a sentence, a formula in language, and so on. So in spite of the fact that today it's very common to say among philosophers that Tarski is a deflationist and a non-correspondence theorist, I think that this is incorrect and that there's very strong evidence that he is
and activity in mathematics, all this model theory, it's closely related to this correspondence idea.
Exactly. And now I wanted to go just to that and go to his 1936 paper on logical consequence. Yes. Now, if semantic notions are correspondence notion, and if Tarski's modern theoretic definition is a semantic definition, then it is reasonable that it is also a correspondence definition, and that what models represent are ways the world could be formally, that is formally possible ways the world could have been.
I understand. I agree.
Yeah, so in this way, I want to say that it's very reasonable. So the way I think about logic is very close to Tarski when you look at it in this way. Yeah. Now, Kripke. The way I look at logic is also somewhat close to Kripke, but somewhat not. It's not close to Kripke because Kripke puts a lot of emphasis on natural language. And he says that the way we have to understand truth is a way that fits in with our experience in natural language. Now, as I said before, I don't think so. I don't think natural language is a key for philosophy. And I think that Tarski is likely to agree to that. So this is a way in which I differ from Kripke. However, Kripke also, in his explanation of his theory of truth, talks about groundedness of properties and the groundedness of truth, and that, for example, of sentences involving semantic notions. And for example, the sentence "no is right is true" is grounded, and the sentence and the paradoxical sentences of truth are non-grounded. Also, the sentence T, which says T is true, is non-grounded, which is not paradoxical, unlike T is false, which is paradoxical. Now, his notion of groundedness, I think, is very similar, also has to do with connection to the world. And he explains it not in the way I explained it, that we need truth and logic for knowledge, but he said, let's look at how a child learns how to use language, including the world true. He looks at he or she look at the world and then say something about it, and so on.
Experimentation.
So, that's right. So there's also an element in Kripke which is similar to my approach.
Yeah.
Now, intuitionistic logic is more problematic for me. And that is because there's a certain sense in which, especially classical intuitionists, think that mathematics is only in the mind and not in the world. I think mathematics and all knowledge is both in the world and in the mind. We really need both of them in order to have knowledge. But intuitionists tend to be constructivists, and then they think that mathematics is a construction in the mind. Now, this is incompatible with the way I look at logic and mathematics. However, you know, intuitionism has developed in many ways. There are now model theory of intuitionism, intuitionistic model theory. So we can also look at intuitionism differently and say intuitionism identifies different formal laws than non-intuitionistic logic. And this, from my point of view, is possible. It is an open question, a factual question. What are the real formal laws governing reality? And I don't want to commit myself in advance to the classical law, even though they seem quite powerful, and I usually speak in terms of classical set theory. Still, in principle, it's an open question, so I don't want to rule in advance intuitionistic laws, formal laws, so long as they are understood as formal laws governing the world, rather than just constructions in the mind.
Maybe the direction, the beacon to go, to follow would be the multiverse.
Yeah.
It's like we're not discussing what is true Newton mechanics or quantum mechanics or whatever, Einstein relativity universe. Well, theoretically, we have to consider both. And I'm sure that in your theory of, how do you call it, transfer or correspondence theory, they can be very it could be well applied to describing intuitionistic logic system, with a proper model theory, or maybe without, maybe with something else instead. Because it's a very powerful idea that, of course, that's the correspondence is the key. But the correspondence, you need some universe on the background which supports this, carries the correspondence, and there we might have a choice. So the picture, maybe if you just relax your approach a little bit and to consider the multiverse things, or more abstract things. There is a formal system and there is a universe, whatever it is right now, but then the correspondence is that it's the formal laws correspond to the real whatever process in the universe.
Yeah, that's, in fact, I've written about the multiverse in this context, but the way I look at the multiverse in the same way that we can consider the possibility that the laws of physics were different than they are, and we can consider the possibility that the actual formal laws would be different than they are. And this is where, for me, the multiverse comes. But I still cannot consider just mathematics being a pure construction of the mind without connection to the world.
Read Wittgenstein. Read Wittgenstein.
Okay.
Okay. Sorry. Thank you.
So, and may I continue with Wittgenstein? Okay. And my question concerns two useful or maybe non-useful dichotomies. First, what do you think? Is it reasonable to distinguish between higher order mathematical cardinality properties and logical properties responsible for, and logical properties responsible for correct inference? And second, as Wittgenstein famously said, there can never be surprises in logic. And in your Dafka logic, there are a lot of unpleasant surprises. But is it reasonable to distinguish between surprises and discovery in normal logic? Yeah, thank you.
Okay, so let me address your second question first.
Yeah.
In my view, there are surprises in logic. And let me give you an example, not surprises in elementary logic that we teach in our introductory classes, because we make it everything especially simple in order to make it easy for our students. But look, for example, at mathematical theories. Look, for example, at set theory. In set theory, we start with certain axioms, and the axioms quite commonsensical and quite simple and very easy to understand. And I think they are not so surprising, the axioms of set theory. But still, when we just have the axioms of set theory, someone who doesn't know the theorems at all and is not familiar with set theory, would be extremely surprised to find out that there are many levels of infinity. There are many infinities. Some are higher than others. I think this is extremely surprising for someone who comes upon it in the first time and has never heard about it before. But if you ask yourself, how do we discover this? How do we discover Cantor's theorem that the power set of a set has a higher cardinality than the set? Then we just use the axioms, which are not very surprising, and then we use logic. And it is the use of logic that leads us to this extremely surprising result. Or if for you this particular result is not surprising, take any mathematical result that seems to you surprising, and the same thing holds. So I think that for pragmatic reasons, we present the logical rules. Usually we choose very simple rules and so on. But even these simple rules, when we apply them many times and in various ways and using various combinations of elements from the axioms, they lead to extremely surprising results. And on my view, you can say that the second level correlate of Cantor's theorem is a logical rule, and it's a very surprising logical rule. It's a logical truth, very surprising one. And so I will contest the claim, Wittgenstein's claim, that in logic there are no surprises. I think there are surprises, and logic plays, especially in mathematics, a very important role in non-trivially expanding our knowledge. Now, to address your first question about the relation of logic and mathematics. So on my view, there is a close relation between them, but they are not identical. There's a division of labor between them. First, let me note something that logicians like Tarski and Lindstrom and others already noted, and that is that the first order logical constants are not formal. Are not maximally invariant, and therefore they are not formal in my sense. So these are logical constants or mathematical properties that can be used to indirectly represent higher level mathematical properties which are formal, but themselves they are not formal. And where Tarski were asked, well, is mathematics formal or not formal? Because first order is not and higher order is. He said, as you wish. My approach is different in this respect. I think that if we ask about what there is in the world, we don't know about mathematical individuals, but we do know about cardinality properties. And therefore, we do know that the laws of cardinality properties are real about the world. They are formal laws, and we know that it is possible to represent them by lower level laws, which are easier for us to understand, yet are not strictly formal. So this already shows that this is, a sort of not an all or nothing approach to the relation between logic and mathematics. But I would say more than that. In my view, mathematics studies the formal laws. Mathematics discovers the formal laws, and logic applies them by building a method of inference which is grounded in them. And so there's a division of labor between logic and mathematics. And we can also see that the development of logic and mathematics, really, they are each interconnected to the other. Idealizing, we can think about it as follows. We start from some very basic logic mathematics, maybe something like Boolean algebra. And then we construct a more advanced mathematics, say up to naive set theory. And then we use that to construct more advanced logic, like standard first order logic. And then we use this logic to build axiomatic set theory, more advanced mathematics. And then we use this to realize that, in fact, in the same way that we treat non-emptiness and identity as logical constants, as logical properties, we could also treat other properties defined in axiomatic set theory as logical and see that they have the same features as the logical properties. This is what Mostowski did first in 1957, and then arrived at a more advanced logic, for example, first order logic with generalized quantifiers. And so I think that we use mathematics and logic develop in tandem. More advanced mathematics, more advanced logic, more advanced logic, more advanced mathematics. And so that's how I see the relation between them.
Thank you. Thank you. Questions? No. So thanks a lot. So yeah, we close our evening session. Thanks to our invited speakers. See you tomorrow.
See you tomorrow.
Bye.
Bye. Thank you.
Друзья, всех приглашаем в лабораторию отметить завершение первого дня.
Виталий Владимирович, а можно вопрос?
Да.
По поводу, я просто, вот сегодня была запись, а завтра, видимо,